So go live on YouTube. Great. It says here that we are live. So hello everyone, and welcome to this discussion about event storming and event sourcing. Today we have a guest speaker. We will be listening to Miron, who is an old friend of mine. Currently the CTO of a company, e-solution is called in Romania, and also doing workshops for companies and consultancy. And in the last 7 years, Miron has used event storming and event sourcing for all the projects he was involved in, saying that this helps understanding and better the requirements, clarifying the needs, model the solution better, all in one. So it's we have here in the room someone who's really into the stuff he's gonna show you. He's gonna debate with you. So without further ado, Miron, the stage is yours. I'm gonna be sitting here quiet and listening to you. So folks, keep firing questions. As usual, we're gonna try to answer the simple ones ourselves here with the help of the group. But the more interesting, the one that call for more debates, I'm gonna raise to Miron also. So Miron, thank you very much for doing this for us. So please.
Okay, hello. I'm happy to be here this evening. Thank you for the introduction. So today I would like to present this combination of event storming for requirements gathering and event sourcing as an architecture. They fit quite one-to-one like hand in a glove. So for me, it's actually the answer to the ultimate question. I can model almost all the applications using this approach. The only applications that I don't use event storming or event sourcing are actually just reporting applications and so on, which are kind of boring. So let's a few words about me. I have more than 20 years in experience. I worked a lot with a lot of technologies, mostly open source. In the last years, I rewrote my neurons. It took me about 3 months. This period, nobody would be able to reason with me because I was switching my reasoning from model-driven to event-driven and event sourcing. But after I realized I managed to rewrite my neurons, everything was clearer, and I use this combination of event sourcing and event storming for everything. I work at the solutions. We are doing a lot of projects with a lot of technologies. We are specialized also in big data, and we also have an academy when we have trainings, and I have sometimes also training at the academy. So let's discuss about what is the most important question when you want to know what the applications will do. It's these annoying questions: what's up? What's happening in the application? Because this is how you start to learn about the requirements. What is happening in the application? The answer to this question usually is an event or a series of events. Users are registered, users are changing their password, users are buying products from a web shop, and so on. All of those can be events. And this event, having only the event on a board, it's almost enough. But it's nice to also have other kind of objects around these events. So in an event storming approach, starting with the events, we also have other objects around it. We have actors, the users, for example, who are doing actions in some pages of views. These actions are triggering events. Events are changing the state of aggregates. On the events, we can react with policies like event listeners that create also other events on other objects and so on. And also we can call external systems like sending an email or so on. In more detail about it, event is the most important object in this approach. It's very important to name these events at the past tense, because we have to get in our mind an event happened and it cannot unhappen. If something happened, that's it. You cannot roll back. If you want to fix it because it was wrong, you add another event to fix it. But once an event is happened, that's it. It's written in stone. Actors are actually roles in our system, so you know which actor what can do in the application. Policies can be event listeners to react to events, to create other events, because sometimes when you have a complex section, you can modify one or more there are more records in the database, so you need to create more than one event. So we can use policies for that to react to an event and create other events and so on. And also in policies, I also consider the cron systems to create to react to the time and create events from a certain hour. These events, if are done by users, we can call them commands, we can call them actions. I kind of make a distinction between these. A command is a simple call on the API that can be also called by another system from outside. And usually for an action, I have two endpoints. One endpoint to display a form or a page to see, so user can complete some data, and the actual command is this submission of this form. Aggregates are objects that are keeping the state of the application, usually tables in the database, but not when we are talking about event storming, we are not really going to implementation detail. It's actually an object when you keep the state. External systems when you want to send emails and so on. And views, again, if you are not talking about certain implementation details, a view can be anything. A view can be a page on a web page, a page on a mobile page, an actual API who's returning some DTOs. It actually be a view in a database is still an option. A view can be anything that actually displays some data. Okay. For a short example, everybody knows how a web shop is working. If we have some strange requirements, for example, products with very, very low stock, maybe our client requires us to update the stock when a product is added to shopping cart. So if we model this as using a storming, you have the page product details of the web shop. We have the role customer who's doing this command or action add to shopping cart. We have the event to product to shopping cart added, who's updating the shopping cart. We react to this event with the policy update product stock. We have the event product stock reserved, for example, who's changing the aggregate product stock. Do you see something not really okay in this diagram, or do you think it's okay?
Me. What does product stock mean? The term.
It's actual object which you have the product ID and the value of the stock. Usually you don't keep the stock inside the object, the product object, because for the product you may have different stocks, stock of the shelf, stock on the warehouse, stock on a car, stock on many web shops, for example, many places. So usually a product stock it's a pair of product ID and stock, the actual number.
Okay.
But are you okay with this diagram?
A little bit, but perhaps other people want to comment on this. But
maybe a netting of the position of the product stock.
First of all, yes, we need to validate that you don't go to the stock on negative. And if this would be actually a real action, a real shop, the events are kind of in different order. What event is happening first time? I go to the supermarket, I take the product from the shelf, then I put it in my shopping cart. What is the first is happening? It's actually in reverse. First event is reserving the stock in a web shop or removing the product from the shelf. And after that, you put the product in the shopping cart. And actually, using this approach, you go as close as possible to the reality. there is a moment, if all these events are not time coupled, there is a time when the product is neither in stock, neither in the shopping cart. It's in your hand while you are moving it. Even if you are using a reporting application to follow the stock in real time for a supermarket, you don't see the stock in real time. You can see we have 5 products in the stock, but the shelf is actually empty because there might be a lot of people walking in the supermarket with the products in their hands or shopping carts, so without getting to having without paying those products. So there is actually a moment of time where these products are neither in stock, neither in the shopping carts, in the people car or so on after they bought it. So if you are starting to model this using events, in my opinion, is the closest way to model actually the reality. Okay. The event storming meetings can be very chaotic. Usually they are. So we are trying to make some order into them, starting in a very agile way to time box some parts of the meeting. For example, in the 5 minutes, everybody is putting randomly some events on the board. After 5 minutes, everybody is reading what events they put, remove duplicates, rename some events, and so on, and then go again another iteration. When we reach to a lot of events, usually there are a lot of events, like filling walls in the room, also walls in the room with events, with post-its. Then we try to make some order into that event and we put them into a timeline. Some events may happen before other events. And after that, we group those events into some area, to some context, and so on. We are trying as much as possible to make some order into a lot of events. Working from home changed a lot about this approach. We switched using Miro boards online. In a way, it simplified the meetings because we don't have this physical problem. The post-its can fall off and so on. But because we are not already in the same room, there might be some problems with communication. But usually, in my opinion, working online on Miro, it improved the event story meetings. If you have a lot of events, you try to put them in a certain order. For example, in a web shop, we can have a lot of events without even having the customers. Just product management events, adding a product, setting images for those products, setting price, updating stock, and so on. There can be a lot of events into a web shop, even without having customers. Then there is another part in the timeline where you have customers, you can register customers and so on. You can have a lot of events before the customers are doing checkout. They are adding products to shopping carts, they are removing products to shopping carts, they are adding products to favorites, and so on. After checkout, again, there are a lot of events regarding orders and so on. Then regarding delivery, regarding invoices, and so on. So no matter how big is the application, it's easy to group those events at the beginning as a timeline, and then even more grouped, like for each aggregate and so on. And from time to time, these event storming meetings, we talk only about a certain moment. Let's say at the beginning, we talk only about events about product management. In the next meeting, we talk about only events about after checkout and so on. We never talk about the entire diagram because it actually gets to hundreds of events. As a result of these meetings, it helps to have a clear specification so you can write Jira stories and so on. But the most important results we are expecting from this kind of meetings is to synchronize our brains. Everybody at the table should have the same understanding and the same expectation about the application. Even if after each meeting you throw anything away, the most important part is all the brains are synchronized. And of course, almost the same importance is having a common language with very clear meanings of the words. So one word should have one meaning, and for one business meaning should be only one word. For example, you can have people in the room, some of them are selling products, some of them are selling articles, some of them are selling items, and so on. You discuss with them, you negotiate with them to have only one word for what you sell. So everybody discussed only about products. Maybe articles, it's something else in the news and so on. So these are the most important results we expect from event storming sessions, to have the same expectations and to have a very clear language, that ubiquitous language from domain-driven design. Also, we have a moderator, and the moderator, one of the most important part of his job is to challenge the requirements. It's annoying 10 people in a room never agreeing of something and changing their minds and changing their minds and so on. Like those meetings looks like they never end. But it's still the cheapest place when our customers can change their minds. We don't have to wait 2 weeks or a few sprints when the customer actually see an application and change their minds. They said, oh, I don't have a customer with one address. I can have a customer with a lot of addresses. I can have a delivery in more than one target and so on, or inventing new keywords and so on. If you challenge all the people to change their mind and challenge the requirements, it is annoying, but it's still the cheapest place to change those requirements in these event storming meetings. It's a challenge, but it pays off on the long term. Good result from this, it's everybody agrees it's not a small project. Everybody agrees it's about some estimation about it. And if you keep the board and so on, it's easier to write stories on it. For example, if you have a customer and you just talk on the first meet, he says, I want a web shop. How hard can it be to have a web shop? I want it in a month, or I need it in 2 weeks. But if this web shop is actually a pair of hypermarkets and so on with with a lot of custom events, a lot of custom functionality, so you cannot use a default already a product for this web shop, you realize you can fill few square meters of diagrams on Miro or all the walls in the room. And after that, the customer will agree, okay, it's not something it can be done in 2 weeks. It needs at least a year or so on to implement. Or if he's smart enough, he will cut some requirements. So the actual implementation will end in a good time for everybody. The hardest part about event storming is getting the right people to the meeting. Usually, the people you want to have in the meeting are the people who are actually doing their jobs and know the business well. And they usually don't have time to come into your meetings, mostly into meetings that never end. It's a challenge, but after a while, when the customers sees the benefits of these meetings, they are starting to show. At the beginning, it is very, very hard to get all the people in the same room. Again, as anything agile, it looks like it never finish. You can talk about an application forever and forever and forever, adding, removing events, negotiating stuff, and you never finish. But again, it's cheapest place to change your mind. For example, let's try a short session of event storming. How complicated can be? Well, we have event, we have commands, we have aggregates, policy, and so on. How complicated can it be to have some user management? Some would say, let's say we have user created, user updated, user deleted. Okay, end of story. We analyzed everything. We are happy. Let's go home. Usually, it's not that simple, because when you create a user, maybe you want to make it active or not. Maybe you want to validate its email and so on. So when you create a user, maybe you need a name, maybe you need an email for it, and you put by default a password and so on. Or you can put that, let's say, email validated false. Then you have a policy. After you create the user, you have a policy to send validation email. Let's say who's sending an email to, let's say, external system. Email validation email sent. So send email. The user is receiving a link on the email, and if you click on that link, the user is validated. And after that, you get the email validated to true. Let's say when you do this validation, maybe you also set the password. Password you set because on the form you click when you receive the email, you also add the new password and you also set the password. You can have the user updated event. Maybe you can do it as an administrator. You want to rename the user. Maybe you have a my account page when you can update your name. But usually, if you login the user by email, so the actual ID or business key of the account is the email, maybe you want to do a separate event because you will need a lot of other validations and so on, and probably if each time when you change the email of the user, you again send email and so on. Let's say it will be here an action to validate user, or let's say set password. So you receive the email, you click on the link, you go to the to a page with a form to set the password, and you validate the user setting the password, and so on. And in the end, you can delete the user and so on from. I will not put an entire diagram. Events are the most important, but you can after you have the events, programmers usually are able to fill the blanks. But usually I prefer to have all the diagram, even if it's not completed inside the event storming meeting, like add user as an action that is going to this event and so on. I also usually put attributes I want to set in an event to this aggregate, because in a model-driven design, you model the aggregates and then you are thinking what you are doing with it. In this approach of event storming, the structure of the database of the aggregates is a side effect of the events. If you don't have an event to set the color of the eyes, you do not have the attribute, the color of the eyes in your database or in your aggregate. So the structure of the aggregates is a side effect of the events. You don't model the database before. So that would be a very short sample. I will not fill this diagram because it will take time and we have limited time here. Do you have questions or do you have something not clear?
To be honest, that's a new one to me, to see attributes next to the event. It's interesting, but it makes perfect sense.
Yes, I switched to this approach after I switched to Miro. On physical boards, it's hard, but when you have this on Miro, you can go as wide as possible. We have no limits and so on. So the diagram is as complete as possible. The main purpose would be to not, the programmer should not be required to fill blanks or to invent words and so on. The actual modeling of the application should be straightforward from event storming to whatever implementation you have. Doesn't matter the implementation details, but should be a straight line, not put a lot of stress and do not require the programmer to innovate the business. It has a lot of to work with technical problems, the programmer doesn't need to fill the business blanks. And after we switched to Miro, this approach helped a lot. And I don't know, on the world physical post-it, it was hard. We didn't do this. But on Miro, we started to add this.
There are two other questions in the chat.
Yes.
First of all, I think the question is, should be an aggregate. There should also be an aggregate somewhere in here, right? Like the
Yes,
user
after some time, you put some aggregate. Usually, I put the name of the aggregate in the event, so it's not a problem which one is aggregate. I just throw an aggregate around it and so on. I don't put all the lines because it is no longer bidimensional. You don't have enough room and there will be a lot of intersections. But yes, you can have an aggregate here. But again, this can be added later because it's easy to add this aggregate later. The most important parts are events. After that, you policies and actions and so on. Aggregates are just put in some areas. Same with actors. Usually, it would be like put an actor here, put an aggregate here, put a command here, and so on. That would be a normal event storming approach. But the diagram stops being bidimensional, so it's hard to manage when you have hundreds of events on the board. So I prefer to have it separate, and usually I have this flow action event. If I actually have so for example, I can add a user, I can create user. If the user is created, this enables me to update the user. If I don't have the event to create it, I cannot update the user. So I also put this kind of relations. So everything becomes a flow from left to right or from top to bottom. And I know on each step of the application, I have this timeline and so on. It helps when you have big boards. And usually the board becomes really big.
Hundreds of events, you said?
Yes.
On one Miro board? Hundreds.
Yes.
Wow.
Yes.
Is that manageable?
I think they actually updated the technology of this Miro because a few years ago it was very sluggish when you had big Miro boards, like it took 20 seconds to open. But sometimes they just fix it. They fix the performance, and it works flawless. If you have some requirements to have everything on your network, not locally, not on cloud. Collabord it's also usable, but it doesn't manage to do such much volume. So you have to split into many boards. Okay. Other questions, or can we move on?
I think let's keep the rest for the end, right?
Okay. It should be simple enough. Again, the challenges are still there. It's hard to get everybody in the room, and it will never finish. Now let's go with kind of Uncle Bob's kind of questions. What's the highest priority for a programmer? Writing performant or optimized code, writing bug-free code, or writing easy-to-maintain code? Okay.
The last one, easily.
Please.
Okay. Yes, that's the priority. It's almost like the chefs in the restaurant, or let's say sushi chefs. They are doing a lot of cutting, a lot of preparing, but half of the time they are cleaning their board. They always have this piece of clothes, and they always clean each few seconds they clean their board. So the same should be also for the programmer. Easy to maintain code is the most priority, because if you have even you have the best optimized codes to fix a problem, usually it's a very complicated algorithm that nobody understands it. That's a dead code, nobody will touch it. Even you have the perfect code, bug free and so on, you're not in a fixed environment, so on. Some things change, laws changes, requirements change, technology change, you have to update the operating systems and so on. And so you have to actually change the code to keep the code alive. But if the code is easy to maintain, even if you have performance issues, you will fix them. just when you actually have performance issues. If you don't have performance issues, you don't have to optimize that code. If it's easy to maintain, you will fix the bugs very fast and so on. So the priority is to write easy to maintain code. As a corollary of this, we go to the discussion about monoliths and microservices. But let's say here we are discussing about monoliths and pyramids. It's the same era, let's say. Even a monolith can be huge, can be imposing. You look at it, it's like a big building. A pyramid, it's like a big mountain. So if you build something from smaller objects, you can build quite bigger. Actually, if you are going to the buzzwords from today, a pyramid is it's a monolith, because the pieces of this pyramid is actually are more monoliths than anything else, because you cannot just move one this piece of rock. But the real challenge is to build this as a monolith. You cannot do. You cannot build something you can see from the space as a monolith. But if you put it on bricks, you can go forever. It's almost streaming. So what's the best size of a building block? You split everything in smaller pieces, but what's the best size of these building blocks? If we remain in the construction area, these are the best size, bricks and roof tiles. Pieces you can take with your hand. You do not need to heavy machinery to put a brick on the wall when you are building the wall. You don't need heavy machinery to put the tiles on the roof and so on. Pieces should be small as possible, so you can actually move them with your hands and so on. You don't need other tools and so on. As small as possible. In the same idea, we can go also in code. You have classes with single responsibility, with let's say only one reason to change them and so on. You can have events. That can be one class. You can have aggregates that are just, let's say, one-to-one mapped to database. You can have command objects, the objects you send when you submit a form and so on. You can have query objects when you send, when you fill a form but filter form and so on. You can DTOs for responses. All of these are processed by controllers in Spring. I'm using a lot of Spring and Spring Boot. So for me, I have this method of controllers in Spring or Spring MVC. Everything is split. You have a model, you have a view, and so on. So all the building blocks of the application are as small as possible. Each one you can take it, look at it, change it, test it. That's the most important part, and so on. Each one has only one purpose, and it's easy to maintain. It's almost like this approach. It's very rare when you need half of brick. It happens, but it's very rare. As open sourcing, we go a step more than, let's say, event-driven. In event-driven, the communication between components is based on events. Events are, let's say, notification. If something is happening in one component, it may choose to throw an event. Other components are listening to the events, and then those events are discarded, because in event-driven architectures, events are just notifications. In event sourcing, events are becoming the source of truth. If you don't have an event, you don't change anything. If you want to change something, you have to have an event for that. It's just the technical implementation of event storming. You cannot do anything to change the state if you do not have an event. And the database is no longer the current state. Actually, the database is the history of all the events you have in the system. I think a good example would be if you have a web shop and you have a smart marketing guy who wants an interesting report. He wants something like, show me all the products people removed from the shopping cart 5 minutes before checkout. If you have a model-driven architecture, you keep the current state. You cannot make a report of the objects that were removed 5 minutes before. But if you have all the events and all the history of the shopping cart, it's easy to build such a report. So if you have the database as a stream of events, there is no report you cannot write. You can write any kind of report. If you have only the current state, you have to rewrite the application to add some reports, and you can add those reports only from today. In the future, you cannot go back. It's a very, very important feature of this approach. Having everything as a stream of events, there is nothing you cannot do. How old do you think is this idea of event sourcing? 1 year, 10 years, 100 years, 1,000 years? If you are going to the programming, we are talking about a few decades, but if you are going to the real world, we are going for more than 1,000 years. We are talking about banking, we are talking about accounting, we are talking about contracts or laws. Even American Constitution is event sourcing. They do not change the first iterations. They are adding new events, they are adding new, how do they call it? Amendments and so on. I think you can go even to Roman Empire or to Babylon to find example of event sourcing. They wrote something in stone. They do not drop the stone. They are adding new information here. So this approach is actually, or should be, the natural way of implementing stuff. And the natural way of approaching business problems is to think in events. Again, it's hard if you are used to model-driven approach, but after you make this switch to event-driven event sourcing, everything becomes more natural. These events can be stored in an event store, like say in a database of events. I'm not talking about the actual product, but it's the idea of a store of events when you can actually query events, give me the events for a certain aggregate, or give me the events in a certain date and so on, or for a certain type. Or the easiest way is to keep those events in an event log. You cannot query it, but you can only stream it. For example, for big systems, I keep events in Kafka. You cannot query anything, but you can stream those events and process them as a stream and do anything with them. But neither approach cannot query actual state of the objects. You have history of the events, but you cannot query actually what the state now or what the state was a few days ago. In accounting is the simplest way to understand this approach. Usually you have the value of your account at the beginning of the month, but for the rest of the month, you only have lines with I earned 5 euros, I spent 3 euros, and so on. Only the history of earning and spending money. Each time when you want to know how much money you have in your account, you have to make the sum how much you earned and how much you spent. To solve this problem, we are going to this CQRS approach, command query responsibility segregation. This is also the result of some iterations, basically separating the databases from databases that are managing the state and databases that are designed to answer questions. This would be like the CQRS format. It's like the latest evolution part. So we can have a command side of the application of the database. Usually, or preferable, it's a transactional database, or when you do changes into this database, you do all the changes as atomically, get, put, and update, and so on. Here you manage aggregates and many. Also, I also write events because I like to write them transactionally, but you cannot actually do many queries on this command side. But if you have the event store or the event log as a stream of events, you can listen to this stream of events and build a lot of query databases with different technologies, but this time each technology you choose based on what questions you need to ask. You don't have to compromise. If everything is in an SQL database, you have to compromise. let's model the tables to be fast on write, let's model the tables to be fast on read, let's model the tables to be good enough for anything but not best for anything. It's a lot of compromise. But if we switch this in two parts, command part and query part, we can actually choose technologies perfectly matching with the actual requirements with the queries you have to ask. For example, if you want to answer the questions, what's the current stock or the current price of a product? Redis is the fastest solution. It gets its key value in memory, it answers fastest possible. This is the current stock. If you want to know how the stock or the price is evolved over time, you can use a time series database, you can use let's say Cassandra or a big data database and so on. So you can store anything and you can have data already aggregated, like by minute, by day, or so on. So it's easy for write reports and graphs and so on. If you want to do complex search like test search, free text search, or faceted search, you also index the same objects in Elasticsearch. Fastest way to answer these kind of questions. So you are not limited by the technology. You can have as many query technologies you need, each one used for adapted for the questions you need to answer. And all of these databases are fed from the same event store or event log, the same stream of events. And as long the event is not optional, the event is is mandatory. So eventually, all these databases will have the same let's say information, but modeled by the queries, but will have the same reality eventually. There is a delay between those between when you are changing the data in the command side and you actually see the data on the query side, but it's not a really problem. Even if you are going for full transactional and you say, I want to be fully consistent in PostgreSQL, transactional, and so on, when you look on a page, the product detail page in a web shop, you are already looking on old data. The validity of the data, it's like until the bytes are leaving the database and you close the connection or the transaction. After that, it's already old data. You are looking on a page with the price and the stock and so on, but on the server, you can also already have thousands of transactions who changes the state of that product. So anyway, you are always looking on old data. Doesn't matter if you actually have also a delay of half a second or maybe a second or more until the data is moving from command side to the query side, because anyways that delay exists. And actually, even in nature, because I'm a big fan of this, and this thing is the most natural way. When you look at something, you don't see the absolute present. When you look at something in your room, it's almost present. But when you look at a star, you actually see the stars how it looked like 1,000 years ago. So anyway, even in nature, you don't see the present, you only see with some delay. So it's natural to be prepared for this delay, to be prepared for this eventually consistent system. You will see the reality, but not in the instant. Okay? It is easy to understand.
There is a question in the chat. What technology to use for event store and event log, especially if the size of the event store can become large, like many events, or large events.
At the beginning, I started with Kafka, and for really large systems, I'm still using Kafka. But let's say to simplify the deployments and so on, the simple solution I will present today, it's just keeping a PostgreSQL database. When you have tables for each aggregate, and also you have an event table, and each time when you do change, you update the database, but you also insert a new row in this event table. You have transactions, so it will always be synchronized. And if the database becomes heavy, you can always remove chunks of historic events into CSV and put them on S3 or cloud or somewhere, because you don't often need the events from one year in the past. So these all the older events, you don't remove them, but you can send them to cold storage or something, because if they are getting older, you need less and less about them. So even if the database becomes very big, just move some part of the history to cold storage, but never remove any event.
There is
Okay.
one more philosophical question in the chat, which is tricky. Who designs these events? The solution enterprise architect or the developers?
No.
Someone is living in a bank. Over there.
All the events are at least named and specified in the event storming meetings. They are named by the stakeholders, by the domain experts. Naming stuff.
Business analyst.
Yes, business analyst. Yes, it's not the job of the developer to name events. We implement events, we test them, and so on, but we do not name add a new event, because if you add new events in the system, you're actually changing the business, and changing the business and responsible for the business are the domain people. Business analysts is domain experts and so on, or just the stakeholders, the people who, in a way or another, will have contact with the application. Again, if you are talking about event storming, or we are talking about event sourcing, they match each other, because both approaches have this important building block, the event. And if we are, and there is a way to, actually there are many ways that it's easy to model the application one-on-one with the requirements. You don't have too many layers of let's say implementation and abstraction, because you can use actually the same words. And actually, I promote a lot of this approach. If the business have a business word for something, use that word for classes in Java, for tables in the database, and so on. Do not translate it. If, for example, programmers are used to do stuff in English, but the requirements are coming in Romanian or German or so on, do not translate them into English. If the business people are talking in a language, use exactly the same words. It gets funny sometimes. Even we had a discussion with my colleagues on a beer. When you program in Java, in what foreign language do you program? Do you program in Romanian? Do you program in English? Neither of them. You program in Java. Those are keywords belonging to the Java programming language. Even the libraries belong to the programming environment. But the business, for the business, you use the language and the words of the business. It adds a lot of benefits a long run. This ubiquitous language, everybody using the same words for anything, and each word having a single meaning. Adding abstractions over abstractions only complicates things without any benefits. So naming things, it's the job of the business people. I do this to an extreme. Let's say each aggregate for me, even in theory, it can be built from more than one table. I actually go one aggregate on one table. So one aggregate is actually one entity in JPA and one table in the database. The event actually, it's a pure method on an array operator. You receive an object, you change it, and return the new version of that object. Don't care where this object is stored and where it will, where you do load this object and where do you store the new version. Actions and commands are just API endpoints, controllers in my case. Policies are event listener or cron methods and so on. So for each object from the event storming, I have a very good recipe exact what kind of object I'm using in the code. There is no need to be creative. There is no need to add abstraction. If I have a few objects in event storming analysis, events, aggregates, commands, and so on, exactly those type of classes I also have in the implementation. On very, very complex application, it's very, very easy to maintain because everything is split in pieces as small as possible. Each of these pieces can be tested, each of these pieces can be reviewed, and so on. For example, how would an aggregate look like? If you are using here JPA, we can have the abstract aggregate with minimal attributes would be an ID because you want to identify it. And let's say it helps to have a version because you want to be as distributed as possible and you can use this version for optimistic locking. An entity, actually the employee, would extend this aggregate and add the actual business properties. And that's it. So the abstract aggregate you write once, and all the other entities you name them what you have in the requirement, in the event storming meetings, and put the attributes you have to put there. How it looks on event? Actually, it can be directly on unary operator, but I usually put this method of copy properties. I use it from Spring. So in 90% of the cases, 99% of the cases, an event is actually moving attributes from the event to the aggregate and so on. So when you have user email changed, you have the attribute email on the event, and you update the attribute email on the aggregate. So you just call these copy properties from the event to the aggregate, and you solve the problem. For example, employee enabled will extend this abstract event, and we just will receive an employee, set it on active, and return the employee modified. If you really want to go fully safe on multi-threading, you can return a new object, but I usually let the multi-threading part to be responsibility of the framework, so I just sync in single thread. I don't care if I return the same object. It's the framework part to make sure this change do not have issues in multi-threading. How do look a command? I can have a form DTO, the object I fill when I have a form. This is part of, let's say, of your view, have some filters and so on. I built an event, I apply it on a certain aggregate, and I give a response. So each command is actually, more complex commands may also do some queries. For example, add product to shopping cart will receive from the outside the ID of the product, but you query the product from the database to get the name, the price, and so on, and you put it in the shopping cart as a complete object, shopping cart item with name, price, and so on. So each of these let's say events are pure functions. You never communicate with the outside, not even setting timestamps or random stuff. Commands, you can communicate with outside, but you just produce events to be applied. You never load the object, the employee object, update it, and save it. All the changes you are doing is from the sending events. I actually use repositories without the save and update or delete methods. I do a lot of queries in repositories, but I never update an object in repository. If each time I want to change an object, I have to create an event and to apply it on that object. Everything is clean, everything is easy to test. This one for each event is just a unit test. For controllers, you can do unit tested or integration tested, also put in the database and so on. Each of these objects have a single purpose and it's easy to understand. Where each time when I write an object in the database, actually I write into two tables. Into the so this apply method, it's loading the object from the database or creating a new object if it's not in the database, applying the event, changing the state of the object, updating that object in the table, but also adding a new row in this event shot log table. that is my approach. That's a little bit different than other people approaches of event sourcing. I do not care about storage. I keep the snapshot after each event. I don't add 50 events, build an edge snapshot, add other 50 events, add a snapshot, and so on. I always, in my events table, event shot log table, that I keep also the event, but also I keep the snapshot of the aggregate. And this is just like JSON, because I like to have text mode, it's easy to read. So aggregate, it's the ID aggregate, class of the aggregate, and JSON of the aggregate. Event, it's the event class and event JSON. I put it separately so I can deserialize them in the exact class they need. I also have this create by create date to know who is actually doing this operation. And this ID is actually a sequence, so I can always read the events from the database in the same order they were applied. Exactly this table, this structure, I can also put it on Kafka. ID of the aggregate, the pair of the ID of the aggregate and the class of the aggregate is actually the key on the Kafka record. Everything else is the value of the Kafka record. So the same implementation and I can use to distribute and so on. But easiest implementation is just using JPA and everything on PostgreSQL. It simplifies the deployment. You don't have many other technologies around. Everything is PostgreSQL. It's not big data, it's not fancy architecture, but it works for almost all kinds of applications, is good enough. Actually, the technical solution is not so important. People are still doing event sourcing on paper. Okay, I will talk a little bit about how I design event sourcing systems, but I will switch also to the next slide. The same approach, I mean, having events is the same implementation. They are pure functions. They don't care if the aggregate is loaded from the database or from anything else. This is how my, let's say, event processor is looking in Kafka. I just have a stream of events to be applied. They have the ID of the aggregate and the class of the aggregate as a key. I group them by key. If I don't have an aggregate for it, it's just an empty string. I apply that event on the current state, and I write to another event short topic the results. So the event processor is actually receiving the old aggregate instance, the new event, and applying the event or the aggregate. And with the same business implementation of the events and so on, I can go on Postgres or I can go distributed on Kafka. So it is the business is actually an agnostic of the implementation. Okay, I almost fit on time. So let's say we have a microservice. Let's say an application. This is a black box. What do I do with these applications? I'm asking questions. I'm sending commands. And if it's a model-driven application, it's enough. But in a event sourcing application, I have a big benefit. I can ask this question, I can receive in my case, all the events applied, all the events that happened in this application, but usually I have it a pair of snapshot and event. The stream of this pair of snapshot and event, so I can add as many query applications I need. One, for example, is it's a Redis application. Other it may be a reporting application with Cassandra, MongoDB, and so on. And I can have as many such query applications as needed. If I need to go fully distributed, Even this black box, I can split it. For example, I can have a command side of the application who's receiving commands. It's putting this command or on an event topic. Event to be applied, let's say. I can have, let's say, an event processor application who's listening to this event, who's producing the event shot topic, this pair of snapshot and event. Again, on this topic, I can listen in on query applications. These query applications are receiving the questions. And if I need to have event listeners, I can have, let's say, policy event listeners, let's say, listeners, who is listening to this topic and writing back to this topic. This is going fully distributed, but only if I need this. Most of the cases when the events are generated by other applications. If the event it's a suite of thousands of sensors, or for IoT, or full imports from big data warehouses and so on, I need to go distributed because I need to work with thousands of events each second. If the commands and the questions are actually user driven, most of the cases it's enough to just have here a PostgreSQL. It's good enough. Even now, talking the PostgreSQL, if you talk the language of PostgreSQL, you can go big data these days. You can use any cloud service as PostgreSQL distributed, and Amazon, and Google, and Microsoft, all of them also have this distributed, and even Lambda PostgreSQL implementations. They can scale to infinite. And if all your commands are actually get by ID and update by ID, this actually scales well. So without changing the implementation of the application, I can go big data very easy. If I really need to scale huge, I can go on the Kafka part. All these are Kafka topics distributed. This is Kafka Streams that usually has a local storage with RocksDB. So this allows me to have this command database. So the command database in the case of distributed architecture, it's a RocksDB implementation of the Kafka stream. It's the fastest database for the command. It's a key value store with storage on hard drive and a lot of cache if you will need. But it's actually even faster than Redis because it doesn't have the network penalty. It's just you working with a local hard disk. And the source of truth actually is this event shot topic. I can lose all this storage because I just replay all the events to build the local storage, and then I start to process new events on the stream. So this combination, it's actually using the fastest technology for command database, RocksDB. You cannot find anything faster than this. And query databases chosen for each kind of questions you need to ask, big data, Cassandra, and so on, or PostgreSQL, or Elasticsearch, and whatever, or Redis databases that are paired with the kind of questions they need to answer. It's the best approach. This one scales forever. Each of these, this one is actually stateless. This one has state, but it's local, it's as fast as possible. Because of Kafka, I'm actually working single thread because everything is managed by Kafka to work with partitions and so on. So this scales, everything of this can scale. Each query database can be distributed. Again, I don't have problems with transactions because I don't have transactions here. So I can have thousands of nodes for query databases, and this scales for infinite. But again, for most of the applications, keeping like this in a monolith, and maybe here streaming or even simple API, give me last 1000 events, give me next 1000 events, and so on. I can fill some reporting databases if I want to do some other business, but most of the application is inside here. Okay. The takeaway about this is, it's an old saying, there are two hard things in computer science: caching, validation, and naming things. We solve the naming things part, delegating it to the business people with event storming. And we solve the cache validation part using event sourcing and using CQRS. So actually you have right ahead caches. You don't expire the caches, you send notifications, look, something changed, update the cache. So this post hardest problem in programming, I solved them with this approach: event storming for naming things and event sourcing for caching validation and actually scaling all the queries. As a recap, the main important question is what's up? Thank you.
Okay. Can I fire some questions at you?
Of course, of course.
Yes. There is a heated debate in the chat over here. I think there were over 50
Okay.
messages.
I'm waiting for it.
Let's try to synthesize the main point. First of all, is it true that, to state the basics, is it true that an aggregate accepts a command and in return produces events?
I didn't go on approach on object-oriented programming. For me, the box, it's not the actual object. The box is a service. The aggregate is receiving the event to be applied. The command is something you receive from the outside of the box. For me, the box is not the aggregate. For me, the box is a system.
To have something in front of us, can you scroll back to the controller that you showed us at I don't know, slide number 10, 12, something.
Here will be the controller.
Here, that's the controller. It caused a bit of rumor.
Before applying the event to the aggregate, I can do a lot of queries because I can receive here an employee ID and maybe I need the employee email. I actually ask the database, give me the email for the employee ID, put the email on the event and apply it.
So before you can accept this command, you have to validate the incoming data,
yes,
right?
Everything is validated here, yes. Actually, if I work in Postgres, I have the advantage of transactionality. So I can have a transaction here and everything is atomic. If I were distributed, I have to be a little bit more careful. I can have events that actually fail with optimistic logging and validation errors because everything is asynchronous and it actually can change the object after you created the event. But working with Postgres, with transactional, I don't have this problem.
So if I get it right, you promote this event as the center of the universe, and then here you have two implementation mechanisms: Postgres, which is transactional and allows you to be more strict, and Kafka, K-table, K-streams that allow you to scale better.
Exactly.
That becomes an implementation detail if you use code like this. Under this code, you can have one or the other. It will look the same.
Yes, the event will be exactly the same. Aggregates are looking exactly the same. If you have the query part abstracted and so on, it will look the same. It doesn't matter if you ask a query, you just lose the transactional part. And if you lose the transactional part, you have to take care, more care about this eventual consistency.
Right. That makes perfect sense. And to make it super clear for people that ask the question. So before the apply call, you would query the current state of the aggregate to validate.
If I need it.
When you need it, to validate the business constraints that you
exactly. I also put the security and everything else, yes. So let's say in the diagram, the command application can actually ask queries. That's the idea.
Yep.
You can ask queries from outside. You can ask queries from the command app. but the actual applying of the events, it's pure.
Makes sense. Makes sense. Now there are some rumors here in the chat saying that I'm gonna just quote it. Business logic is in the aggregate, not in the events. Is it just model-driven thinking?
I don't think it can be wrong. I mean, you can always add some, let's say, this apply. You can put it in the actual aggregate. It's here. Email changed, but you need to have a reference to the actual storage and so on, or to the service to apply and so on. And it becomes more or less an active record, not a stupid object. And it begins to have more than one reason to exist.
Okay, sync responsibility. Okay.
Actually, for me, the structure of the aggregate, it can even be a map. I don't care. It's the most simple object possible. The business is in events. And each time when I'm adding a new event, I don't touch the other events. I'm just adding a new event, a new class. I can unit test and so on.
Okay. 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 And in the controller we just saw, when you said you validate data, if that validation is based on a select in a Postgres within a transaction, okay, nothing to worry about. But if that involves calling a REST API to the read model,
as long as I have only one apply at the end, I don't care. As long as I'm not doing reads after I send this apply, I don't care. And if I work with transaction, even if I have in a policy a call that may crash, I roll back the transaction. So again, I don't care. But it's important, I do not use any other calls to change the state. All the remote calls, queries or API calls or whatever, are only asking questions, not changing state. So I don't care about this. It's not a problem.
okay, it's a let's say original approach. How to put this? Indeed, maybe under the influence of domain-driven design, I see the business logic sitting inside the aggregate more than in the event. But
Let's say I have a problem with object-oriented programming. It's good. It's one of the best approaches. It's an improvement over procedural and so on. But object-oriented programming has a problem. You do not know when to stop complicating it. We can add a lot of design patterns over design patterns of design patterns. The code will look complicated. Art will be art. It will be beautiful, complicated, and so on. But you don't know when to stop. If you are reducing the complexity and go as much as possible to procedural, you just have structures and procedures. There is a line. You cannot go less than that. But if you go to OP, there is no limit how to complicate things. And I don't like it. I'm going as much as possible to the procedural. If I can solve a problem using procedural, there is no reason to go to OP. If I can solve something functional, I don't need to go to OP. I still have OP, I have abstract classes, I inherit and so on, but I don't overuse object-oriented programming.
yeah, people are talking about validation, more and more about validation. They were worried about what happens when you validate the incoming command.
Yes.
You are looking at unable to reach the read model, the read application. If we are in a single application talking with a single Postgres, very little things can go wrong. It's the same database next to you, but the tricky part happens when you call another system to get the data.
Yes.
Can't this cause problems? Like stale data,
Yes, for that I have this version in the aggregate for optimistic locking. So I can read a remote database, not a transactional one. I get the object with a certain version. I can put that expected version on the event. But when I apply the event, if I don't find that version, I just throw an exception. So actually, again, that's a small different implementation detail. On this event show topic, if I go full distributed, I can have failed events. Because let's be fair, anything in programming can fail. There is no such thing as I have an event, I apply it, and will never fail. It always may fail for some various reasons. So on this topic, I can have failed events with optimistic locking, with validation, last validation inside this, and so on. So if I'm fully distributed, here I have the transactions, but I can have failed events here, and I can react to failed events. That's the difference. If I'm working with the transactional for the entire app, I don't need to have failed events because I just roll based the transaction. But if I go distributed, I can have failed events.
It's the price to pay for scaling fast. For
Yes,
scaling.
yes. Because in this approach, the only blocking I have is when I apply an event on a certain aggregate. I only have to take care that on each aggregate, everything is happening in single thread. That actually is the only blocking part. And for this is managed by Kafka Streams and Kafka. But everything else, it's asynchronous, eventual consistence. So I have to take care about things. But again, this is nice, this is beautiful. Most of the cases you don't need it. This is good enough for many applications, and you hit the top, the ceiling about the scalability. It's easy to switch to this one. Not very easy, but you can migrate from this approach to this approach without losing the business. Anyway, complex reports and so on, the ones that are hitting the database are outside the app. So anyway, I have some scalability. You are on mute.
I was saying they were just maybe listening to the stream of events in that case.
Yes,
the report.
yes. And because on the event, they're receiving also the snapshot, they do not need to rebuild, rehydrate the aggregate. They have the snapshot here. So the actual implementation of the event, it's only here. Everything else is just DTOs or JSONs to be read and something. Because on this event shot stream, you can have two kinds of listeners. You can have query applications that are getting the snapshot and index those objects from various forms and so on, or maybe even doing aggregations. Or you can have, let's say, event listener application. Maybe you want to react to some events from another application to do stuff. It's okay. It's even better you have the event. Let's say you have the event that user was disabled, but you also have the email of that user to send a notification to him. Look, your account was disabled.
So you are drawing in the snapshotting into the producer of that event shot.
Yes. So I do not need to move the business. I do not need to have to distribute the event class from here to here. Here I just model a DTO with the same structure or even less structure if I need only a few fields. That's it, I don't care. The actual business is here. I don't need to version events because I will never recall the same event from the past. I already have this pair of snapshot and event for it. Even if I change the implementation of an event, it applies only from now to the future because I already have the snapshot with the last implementation applied. I know some people would call this command streaming, not event streaming, but it's arguable about this. Command for me is something from outside. In a command, I can do queries. Events are pure and so on. So I never talked with outside, not even random number generator, not even time when I apply events.
So the command comes in, your command app does
Yes.
all the queries necessary to validate it, enriches all the necessary data, assembles
Yes.
this event, which
Yes.
fires to the event processor that then wraps the new event over the existing state in a
Yes.
case stream or a table in Postgres, depending
Yes.
on the package.
Yes.
And then it fires out an even shot with the event that came in plus the newly computed snapshot.
Exactly.
And the command app is like a facade, gathering more data and guarding against invalid.
Yes. If I go distributed, I still need to have validation here because everything is eventually consistent. But it's okay if the price to pay, it's a simple price to pay if I want to go fully distributed.
It's always the case. So yeah, all the discussion in the chat is also wrapping around the same idea. If you want to go super scalable, you have to take on some risks about consistency at some
Exactly.
point. You
Yes.
can't just completely avoid it. So yeah, it's a bold design. You are trying to explain us both strongly consistent event sourcing, both weakly consistent distributed event. It's a very big challenge you're taking in here. Very
Because it's simple. I'm starting with the requirements. Requirements are technology agnostic.
correct.
I don't care about the technology. I have events, I have aggregates, I have event storming. Then I implement those requirements again as decoupled as possible of the infrastructure. Pure functions in case of events, functions calling some external queries and building events in case of commands, or listening to events and producing other. Again, also this event listener can do queries. Because in the end, command and policies are almost the same, because a command is actually a policy listening to an event from outside.
From outside, and the event listener is listening to an event from inside.
From the system, yes.
From inside.
Uh,
And the people are mentioning change data capture, like CDC, when
Yes.
you fire out an event shot.
Again, the technology around here, as long as I have the table, the event show log table, I don't care the technology how I extract it. I can do some polling, just an API, events of an offset of an ID, or I can do CDC. I can do anything. It's as long as I write here transactionally in both tables, aggregate plus event shot table, event shot. Here I wrote into them transactionally.
I think the confusion is that the example you showed is a very simple one with just
Yes.
copying the properties over onto the aggregate. But this is not what you will always do.
Yes,
You showed
that's why I
that-
put, yes, I put the event here. I just set active. I don't copy anything. I
There you
set
go.
active. I can do anything. So for example, I can have event for the stock. I can have an event to update the stock, or I can have an update that increases the stock. It's still in this pure function. To have two different events and so on. Most of the cases, events are just copying properties from the event to the aggregate, but I can have events that are actually setting stuff, doing business, doing computing and so on.
Maybe firing more events in turn.
That's the policy's job.
That's the policy's job.
Yes, that is actually a listener who receives this event shot and creates more events.
Even listener on the bottom that was there looping again.
Yes.
Cool.
Of course, preferably you generate events from other aggregates, not from the same aggregates, because it's ugly.
Then you will listen to the same event yourself again.
Yes. For Kafka, actually, I put a counter so I do not get to a Stack Overflow, because in Kafka I can go forever. In Postgres, I hit a Stack Overflow, but for Kafka, if I design the system wrong, I can get into a loop that goes forever. So I put also a counter.
Okay. I think one of the folks, yeah, I think I've covered most of the questions. There is one last one that I keep track of here. Please rewrite your question on Zoom or YouTube if you want another debate to happen. But the last thing I keep track of here is just to confirm, how do you get the current state of the system in an architecture like this? Do you use REST HTTP request, or do you prefer to have events carrying data? So someone in the system out there wants your stuff. What's the preferred approach?
That depends on again going on microservices. Okay. That's a good question. I can have a big monolith. I have no issue. All queries are inside. If I have 2 or more microservices, I also usually can have an MQ here, which is still Kafka. This is writing events into the Kafka. This is listening to the events from Kafka, and is creating its own query model. This is the second application, has its own aggregates, but it has also query models from the first, so it can do joins and so on.
So it will keep updating its projection over
yes,
the data.
Exactly. So I do not need to have this.
Right. So you prefer to use events to carry the data, even carry state transfer.
Yes.
Right. Okay. I think one more question here. Are events described here domain events or notification events? But let me first understand the question. Domain events is something that is relevant for the business. Notification events can also be relevant for the business. I think that the question is...
No, I understand the question. All the events are domain events. If I need to have integration events, let's say, it's okay. Here I have streaming. I can react to the domain events and throw integration events. No problem. Because here I already have streaming and I do whatever I want with these events. So here I can have integration events.
Okay.
They are processing on the stream, on the outlet of the application. I don't care. Again, I don't need to change the app.
Okay, correct.
If I need to go to external systems that I do not need to, they need to react to my system, but they have their own events, their own APIs, whatever.
Yeah, that's exactly the point. The second part of the question is, do you share domain events? The stuff that moves in your event shots is like domain data, right? It's like your internal structures.
It's internal structure, but as long I am in the same bounded context, I don't care. If I want to go in the outside the bounded context, I have these integration events.
So when you leave your bound, when shipping talks to warehousing, that's an integration event crossing the boundary, right? One listener on one side, and then that integration event becomes like an API between the bounded contexts, in a sense.
Yes. And this is normal streaming application. Again, very simple, Kafka Streams, and so on.
I think that answers.
So adding a new consumer for integration events does not change anything in the existing structure.
Right. But it's important, relating a bit to the classical domain model, to the model-driven. That integration event is like the external DTO.
Yes.
The external DTO. Okay. Very interesting. Very interesting. I can see you run a lot through many. I mean, it's obvious that you've explained this dozens of times already.
I also tried a lot of variations of this. Yes, this is the last I ended up. I started with the OP approach, so everything is inside the object, but it got uglier and uglier and uglier when I hit with when I met the real world. So I've started to split in smaller pieces and so on.
Yeah,
this is not the first iteration. It's after a few iterations.
I can see that. And it's like going exactly against the domain. It's like fighting the domain. Yeah, interesting. It's definitely deserves a thought for sure. All right, folks. I think Miron answered most of all, as far as I can tell, questions. Maybe if there is one last point, otherwise I will.
Yeah, I have a question. How do you formalize output of all these meetings, all these events? Do you do it manually, or whereas, I mean, how do you formalize all these events to real documents which can be taken then into account by developers and other people in development? So is it manual process?
Unfortunately, that depends a lot of each project, each team has a different approach because, again, event storming is hard because it's hard to get the right people on it. So depends on the customer. We have customers who send their people, and with their help, we have really full diagrams. And so the product owner can write stories from the diagrams. We have customers less involved or with less time to involve in these meetings. So we have our own co-product owner and so on to help to fill the blanks. And again, there were teams who were working to consider the Jira stories as a source of truth. So they write the stories from the diagram. But if we have time and also developers are reviewing the diagram, it's almost complete in the diagram. So you just do a cut from the diagram and put it in the Jira. But the rule is still Jira is the source of truth for requirements. But again, depends on mostly on the team or the customers and so on.
I thought that the question was Avro or JSON schema or wiki page.
And it's I mean about how to use outputs, and yeah, you can, if you have huge organizations, you have to take into account people who can create actions for other people. Just JSON document means nothing in AWS, for example.
Okay, as I still didn't understand. So the actual format of the topic or what?
Just a comment. So when you complete event streaming, you have to use it somehow, and only tickets which can be actioned provide value for company.
After event storming, I mean, after event storming, the result of that event storming, how do you formalize the result, basically?
The product owner, so in the expected part of the expectation from the event storming is not the requirements, is not the functional requirements, is not that's internal organization. Each one is treating differently. So I do not expect to take the event storming board, give it to developers, and that's it. Usually, as a product owner, it's writing stories from it and so on. So they can reference part of the board or do some screenshots and so on. But in most of the cases, it's normal agile or Scrum or Kanban. You have stories and you implement them. But these stories already have the keywords defined. Implements that event, implements that action, whatever. It's easy to define user acceptance criteria. Just throw some variations, and but that internal organization stuff to the team is not something imposed. And this varies a lot from different teams, different customers. I would like to have the board as a source of truth and only the board, but you cannot put all the information there because you need to get out of two-dimensional. It will be too big, too complicated. So the actual complete information are the stories, messages for validation, the actual labels, maybe mockups, maybe a lot of stuff. They stay in the story, not on the board. Actually, there is another approach who's putting each event you go to a view. I think it's model, event model, whatever. It's another approach of event sourcing. They actually put the mockups between actions and events and so on. You do an action, you go to an event. From that event, you are going to a mockup, to a view. In that view, you can do an action, you do an event, you go back to a view. So they removed the aggregates from it and replaced it with the actual views and mockups. It's a good approach, but
the UI-centric approach.
yes, it's a good approach for some applications. I tried it, but for very complex apps, you don't have enough surface to cover.
Awesome. Very cool. All right. Would you share the slides with us? Is there any chance you can make a PDF to put it on the community?
Yes, I will share the slides, yes.
Thank you so much. Folks, it's been half an hour more than the time. So I will thank you all for joining and for the wonderful questions, the debate you had. I saw you answered each other. Thank you very much. So Miron, great, thank you. And thank you for taking the time and for sharing your accumulated experience. Good. All right, great. So have a great evening, everyone. And
See you.
yeah, see you next time.